Manufacturing Matters is an MFG radio network production brought to you by GIE Media's Manufacturing Group as industry experts take deep dives into the latest manufacturing matters, whether it's new innovations, products, technologies, and emerging markets that help you understand better why manufacturing matters to you and also to the top companies in the medical, aerospace, defense, and electric vehicle manufacturing industries.
Hello, everyone. I'm Elizabeth Engler-Modick, Editorial Director for GIE Media's Manufacturing Group of magazines. Today's medical developments, aerospace manufacturing and design, defense and munitions, and EV design and manufacturing. Your presenter today is Lawrence Cruciana, the founder and president of Corporate Information Technologies, where he focuses on identifying and mitigating information-centric cybersecurity risks using risk-informed methodologies. With more than 20 years of experience in regulated industries, Lawrence brings unique insights into third-party supply chain risk mitigation. Most recently, his emphasis is on those risks introduced by smaller organizations and managed service providers into larger commercial and government organizations. His efforts in this area are reflected in his nomination to the CISA Joint Cybersecurity Defense Collaborative as a remote management and monitoring subject matter expert. Now, before we head into his presentation, I would like to thank our series sponsors, ISCAR and Renishaw. ISCAR is the largest of the 15 companies comprising IMC, International Metalworking Companies, and has been a leader for nearly 70 years in the development of a dynamic and comprehensive line of innovative precision carbide metalworking tools. They have developed industry-specific solutions to optimize productivity. They understand the unique requirements of each industry and continually improve and introduce new ideas for machining intelligently. And Renishaw, they are a global leader in developing technology that supports manufacturing process control. Renishaw offers an advanced range of calibration, measurement, positioning, and inspection solutions specified by leading OEMs around the world. Renishaw encoders, calibration, and measurement systems enable superior process control down to the nanometer and picometer levels. So with that, Lawrence, welcome.
Fantastic. Thank you very much, Elizabeth, and thank you, everyone, for taking time out of your day to come and learn about this. This is a topic that is near and dear to my heart, and I am grateful for taking time. Again, my name is Lawrence Cruciana. I am the president of Corporate Information Technologies. With a couple of decades in this business, I have had the privilege of working with organizations of all sizes and complexities. And today we're going to talk about some exposure that is shared on the cybersecurity side across the supply chain. If you could go to the next slide, please. Our agenda really is fairly focused. We're looking through at the ecosystems that are available within. And really, I'm not going to say the supply chain, I'm going to say your supply chain, because this is quite universal. We see this pretty much everywhere. We're to characterize some supply chain attacks, quantify the risk, and looking at some common areas of shared exposure in those risks, and I'm going to provide some tools to help close some of these gaps so you can take some action. Next slide, please. One of the things I wanted to share with this group is this topic is something that has been circulated for some time. Supply chain attacks are nothing new. Beginning back in 2017 at the RSA conference, I brought this topic, specifically the risks that smaller organizations bring into larger enterprise organizations, and that has cascaded through the industry. Long before we saw the in vogue concept of supply chain attacks, this was something that we were seeing in our practice on a regular basis. I had the privilege of presenting this with the NCCOE through NIST, FBI InfraGard, IMTS as an industrial show, as an example, with these types of topics. This is a topic that is very important, something that is only getting bigger. So again, your attendance here is quite valuable. So thank you. Next slide, please. Just quickly for the lawyers out there, everything that I'm talking about here today is really not intended to be fit for a specific purpose. So do your homework and always seek professional qualified guidance relating to cybersecurity or legal business. Now, next slide, please. Fantastic. Let's start by understanding the components of supply chain. Next slide. So first, let's talk about what an ecosystem is. I think we all understand what a manufacturing ecosystem is, and that is an interdependent and related group of systems and processes that are often today supplied by disparate entities or organizations. These ecosystems exist throughout our hardware, our business relationships, but also our software. Next slide. Every one of these points on the screen is an example of one of the elements of an ecosystem, and each one of them have their own ecosystem. Increasingly today, on the OT side, on the HMI side, and the IT side, we see a myriad of third parties, of other vendors, of software control, of just ecosystems inside of these ecosystems, all supporting this. Very often, this flies under the radar of our risk managers, surely of our IT professionals, because it's not easy to see them. They're not obvious. One area where I've spent a lot of time, that is in the IT MSP space, the IT managed service provider space. This is something that I'm working at the national level to improve the risk management, risk containment of IT MSPs. And most IT MSPs don't even have an idea that the rest of these ecosystems even exist in manufacturing environments. This is an area where there are these ecosystems in the ecosystem, and that we all have to really appropriately mitigate risk. Next slide, please. So first, let's just set the stage and differentiate between IT and OT. Now, I speak an acronym, so I'll apologize for that in advance. If there's an acronym that I throw out there that you're not familiar with, ask the question. I will try my best to make sure that they're all explained as we go to. But I do speak an acronym, and this is an acronym-centric industry, so bear with me as we go through this. And in our IT systems, we see these ecosystems of traditional IT management, and that's, I'm not going to name vendors, but we have the systems management, the internal management of the computers, of the laptops, of software assets. We often see third-party MSPs, those managed service providers, using remote management and monitoring, or RMM tools. We have remote access software. We have cloud-derived software, things like Office 365, or any myriad of the third-party software suppliers. We have security tools, policy analysis tools, productivity and line of business software. All of these things are operating in our IT ecosystem, and every one of them have a direct, they introduce a direct risk to our OT systems. Let's take a look at that on the next slide on the OT side. So in our OT side, we have, of course, material supply chain. The supply chain is incredibly complicated with our ERP, our MRP, the MES, the third-party support vendors that are managing all of the software tools that we're using, force analysis, materials analysis, that entire supply chain. We have our vendors, oftentimes of how we're receiving orders in, or even our customers, how we're transmitting orders and just-in-time information out with things like EDI, or some of the OMS and just-in-time automation tools. All of these ecosystems, both on the IT and OT, which I'm including here, that includes IoT and IIoT, all of these ecosystems introduce risk. Well, let's go to the next slide, please. So for those that are of the ISO mindset in the world, I'm looking really at level 2 up of the ISO ISA 95 model. So increasingly, where we see the risk, and what I'm going to be focusing on this conversation, are those things that are attached to our IP-based network. That includes systems-based, server-based, and cloud-based software that is in this enterprise interconnection model. Next slide, please. To unpack this a little bit, kind of what functions might fit inside of that ISA 95 model. These are kind of the business functions, the manufacturing functions that line up with that, just to set the stage. Next slide, please. Now, I know for me, it's often easier to kind of see like a product or a technology that I might be familiar with and say, like, where does this all fit? Um, every one of these logos that are on here, these are various companies that operate inside of these ecosystems. All of them surround one common core theme, and that is information. That might be manufacturing information, it might be IT information, but it's information. And ultimately, that is what the threat actors that are our adversaries here, that is ultimately what they're after, either manipulating it, restricting our access to it, or stealing it outright. Next slide, please. So understanding where this kind of all fits, what this ecosystem, where we're focused on, let's talk a little bit about where some of these common attack vectors end up and what they look like. So let's move into this. So really, the attacks are in two principal types: upstream attacks and downstream attacks. And let's go to the next slide. And really, what we're talking about here is fundamentally our software and access supply chain. Upstream attacks often target smaller organizations. Those can be anywhere inside of your supply chain, anywhere that has information that you may provide a subcontractor or a smaller organization that supports one or more functions of the business. Those small businesses are very often less capable of all things cyber. They have fewer resources, they have fewer people, they have usually little to no capability to detect or defend against an attack against them, especially one that isn't as disruptive as something like ransomware. An attack that an upstream attack very often is targeting a larger entity and will come in through the supply chain. There's a million examples, and we'll talk about a couple. But one thing I want to focus on and emphasize here, and that is the ease of obfuscation. There's so much noise. There's so much information in these upstream attacks. It's very easy to hide. So it makes it very difficult for these smaller organizations, these small businesses generally, that are quite often the targets of these. It's easy for the attackers to hide in that noise. The small businesses can't see them, and equally, there's a lot of noise going upstream into their customers or into that supply chain, and it's very easy for the attackers to just kind of blend in, and they got quite good at this. Let's go to the next slide, because I want to unpack this a little bit, just to quantify what's this small business. Very often I'm speaking with enterprise organizations, and I don't know if anyone here has had the fun of asking the question of your vendors or your customers, what is a small business? I ask that question often, and I've had questions that range from, oh, anyone with fewer than 10,000 employees down to, oh, anyone with about 10 to 20 employees. Officially, the Office of Management Budget says that any organization that has fewer than 499 FTEs, those are the ones that fit inside of the small business. If we look at the size of the U.S. economy, that works out to be about 99.6% of the organizations out there that, generally these small businesses have revenue of less than $100 million. So 99% of the U.S. economy is comprised of organizations that have revenue of less than $100 million. Let's go to the next slide, because I want to unpack this a little more. There's been a lot of study on this, and I think it's relevant here. The U.S. government, specifically the Department of Defense, has done a fantastic job of quantifying, like inside of the defense industrial base, what does this look like? And I'm using the defense industrial base just as a characteristic example of what the larger economy is. And I think that this fits very well. So if we were to take that same statistic of firms that have fewer than $100 billion in revenue, quantify it in this kind of block graphic representation, and slice how many full-time employees that each of these organizations have, you'll see that all this blue, that is the vast majority of the U.S. economy, the vast majority of the organizations that are out there. And on average, they have 11 full-time employees. I just want to pause for a second there. A small business with 11 FTEs generally is not going to have anyone that's dedicated on cybersecurity. They're not going to understand the ecosystem risk. They're not going to understand these complicated and always moving targets. So it's something that this really is a team sport that we all have to play with. But let's slice this a little bit even further inside of just the U.S. DoD supply chain. These are the next slide will show that the firms that have registered with PIE through the US DoD, that it works out inside of the defense supply chain, that about 63 firms comprise that, less than 1% of the US economy, and 71,000 firms represent. This is the vast majority of this is small business. The attacks are coming in to small businesses. So often I hear from smaller organizations, oh, we're too small. Like, no one cares about us. We're making widgets. Or I recently had a conversation with someone who made specialty screws. And they, look, no one cares about what we do. They absolutely care about what these small organizations do. And it's something that, whether you're with a small organization or an enterprise organization, this is something that we all must care about, because we have to evangelize and promote this, that the attackers are here and they are taking advantage of these smaller organizations. Let's look at the next slide, because I think that we really need to just to focus on some data in the SMB space for just a moment. SMBs, small to mid-sized businesses, those with fewer than 499 employees, they are far more likely to become the victim of a successful attack. They are very often to suffer catastrophic results from those attacks. The data consistently shows that time and time again. They don't have the complicated detection and response capabilities, and very often, if they have an IT function at all, that IT function is someone who is focused on one or less resources, but that's focused on specifically keeping the lights on, helping that business with their IT and technology systems that makes them money. And that may involve everything that has a wire hanging out of it. So all of the HMI, all the OT, all the IT, all of the things very often are inside of one person's duties and responsibilities. So it turns into a significant issue. Let's look at the next slide, because I want to look at just some data. Now, I'm an engineer by training, so I like measuring things. I love measuring things. If we look at the Verizon Data Breach Incident Report, which is an annual report that Verizon combined with a number of industry partners, which includes FBI IC3, a number of industry partners. They have continued to report that small businesses are targeted at a nearly 2-to-1 ratio. In 2022, that approached almost a 3-to-1 ratio. They have less than 20% on a per headcount basis of the cyber funding as a small to mid-sized enterprise, those with 500 employees and up. But the adversaries that do successfully infiltrate a small business, that they have a significantly longer dwell time, the time that they're in the environment without being noticed. And that's important. Imagine if someone had access to all of your electronic communications, everything on all of your systems, all of your computers, all of your servers. Imagine if an adversary had access to that for 3 to 6 months. They would know a lot about the business in 3 to 6 months. And that is what we're seeing in that small and mid-sized business space. The trends are not new. This is not a new thing where small businesses are being targeted. We have seen from about 2018 forward, using the Verizon DBR data, we've seen these trends to continue this way, that the smaller organizations are being targeted more, they're being targeted by more sophisticated threat actors, and that the threat actors are existing and operating in those organizations for a longer period of time than their enterprise counterparts. Let's go to the next slide, because I want to talk about the length of time that this issue has been happening. Now, going back to 2019, 2020, CSO Online, which is an enterprise security-focused magazine, they were covering the supply chain attacks that were happening then, lower sophistication. They went so far as to say that everyone should be very wary of third-party providers, and we should be doing something in which to quantify what those risks are, quantify the exposure, and limit the access that our third-party providers have. Let's go to the next slide, because this point, I think, really can be typified by seeing the data exfiltration, the theft of intellectual property. Now, there's a million characteristics, a million attacks that we can look at, a million things that will show that these attacks are successful. But I think that a picture is worth 1,000 words. Now, I'm an aviation enthusiast, by no means am I an expert, but those two drones look awfully similar, just saying. So let's go a little further along this path. Go to the next slide. These upstream attacks really focusing in the small with the intention of grabbing data, stealing data, infiltrating a supply chain, generally of a larger organization. Now, the opposite of that is a downstream. So let's go to the next slide and talk about downstream attacks. So downstream attacks, these are the ones that make news, right? These are the ones that we see all the time. They're big, they're flashy, they're sexy. It ends up taking down a whole bunch of organizations. But let's unpack what they are so that we all can just understand this a little more. A downstream attack, they rely on one-to-many relationships, generally a harder, more difficult target for the adversary to take out or to infiltrate that supply chain, but they rely on a one-to-many relationship. They target key vendors, suppliers, or code repositories. Now, I know I don't want to get into the point with software just yet. We're gonna get there. But code repositories are these shared resources out there, that software that you might be running on a computer or on an OT system, that it might need to go out and grab and download a package, download a piece of software that's complementary or supports some of the other software that it's running. And so these downstream attacks have been very often targeting those code repos, things like GitHub, just to name one. Now, downstream attacks are very difficult to detect. They are often incredibly sophisticated threat actors, very often nation states, and they thrive on the fact that there's unknown endpoints. And I'm going to just for a second go into a little bit of technical detail here. And what I mean by unknown endpoints is that if you have a piece of software that needs to connect to the internet and download various pieces of software to support its operation, well, how long is that documented? Like, very often, code developers, surely historically, have never had to document any of those things. The fact that they're downloading Python libraries, or they're downloading things from GitHub, or they're downloading other things from other resources on the internet. And so it's very difficult to know what normal looks like by these pieces of software. And so these downstream attacks have for years thrived on the fact that there are these unknown endpoints. We don't know what normal looks like. So we can't necessarily find when there's something that's not normal in our operations. Now, these downstream attacks are typified by the attacks against managed service providers or third-party software service providers or software tools. Let's look at the next slide. We're starting unpacking this a little more, just to characterize kind of what this looks like. I don't know, I'm an engineer, I like pictures. So I drew a picture here. Starting on the left-hand side of your screen, we'll see a threat actor introduces some malicious code. It might be a backdoor, it might be something that's stealing or looking for certain types of information. It would infiltrate some shared resource. In this case, I'm using GitHub as an example, an update repository, but there's a million examples of this. The point, though, is the threat actor compromises something central, and then there's a download of this software to many, many customers or end users. Next slide. The point there, though, is it's a one-to-many relationship. Now, I think we've all probably heard of the SolarWinds attack. That was one of the most damaging in US history. It successfully infiltrated a nation-state sponsored attack. I should be very clear. A nation state was able to infiltrate SolarWinds their network management. It's a network management software, and they gained access to some incredibly sensitive areas of the national security infrastructure because of the use of that software. They were very clever, very clear in how they carried out that attack. And as a bonus, they got hundreds to thousands of other companies that were using the SolarWinds software. They got access to those as well. One that's been in the news recently, the Confluence attack. We've seen the same thing with remote access software such as TeamViewer. One that was very big in the managed services space that was really kind of ripped, just shook a trimmer through the entire managed services space, and that was against Kaseya. In this attack, a threat actor compromised the update repository, the update function of the Kaseya remote management and monitoring software platform, and then thousands of endpoints, about 1,500 customers were affected by this, that the threat actor carried out a ransomware attack against about 1,500 companies. And so in this case, and I'm going to just spend another second here, in this case with the Kaseya attack, this was a piece of software that a managed IT service provider introduced into the environment of their customers to allow them to manage and monitor all of the different workstations and systems that are out there. Now, by and large, most small businesses, the most recent estimate about 82%, but most small businesses utilize the services of one or more MSPs. So the attack surface there is huge. In Kaseya's instance, about 1,500 were compromised by this attack against Kaseya. Those small business entities that were the customers of the IT managed service providers, oftentimes they didn't know the name Kaseya. They had no idea that the software even existed in their environment. And that is where these downstream attacks are so incredibly damaging and why it really is a team sport. I can't let a downstream attack go without talking about the LastPass attack that was successful just last year. And one, I actually updated this slide deck this morning to include Okta. Now, Okta is, and we're going to digest this or dive into this a little further. Okta is a security tool. It is an authentication and access management platform. It is really one of the most sensitive functions of security functions inside of an organization. Let's go to the next slide. And Okta was a victim of a downstream attack. We're gonna unpack it in a second because it's really an interesting story. In the IT looking less in the IT space, looking at the IoT space, I often am challenged like, hey, look, we have all these HMI, we have all these sensors, we have all of these SCADA equipment, we have all this gear. All that IT stuff doesn't matter to us. I'll introduce you to Ripple 20. Ripple 20 is the name of an attack that spawned out of 19 0 days, 19 vulnerabilities that were found, and of those 19 vulnerabilities, there was a small TCP/IP library that was used across all kinds of different technology. You'll see on here that we have Schneider Electric, we have Rockwell, we have MaxLinear, right? We have IoT and SCADA equipment that was affected, just like wireless vendor Aruba, Cisco, and IT vendor Dell. So we have this one vulnerability, this one small software library that was found to be vulnerable and ultimately allowed backdoors, existed and impacted IoT and IT equally. Let's move to the next slide. Now, if we look at this holistically, the European Union, the ENISA, the European Union's cybersecurity agency, they've done a very good job of quantifying, measuring, and reporting this. I think they've been more transparent, or surely more involved in the supply chain side than what we've had in the US, at least up until quite recently. And in 2020, these supply chain attacks really started taking center stage. They started looking through the EU members, large enterprise organizations that had direct analyst reporting to them, and they found that there was a 66% year-over-year increase in attacks against the suppliers of software systems. So going from 2020 to 2021, 66% increase in attacks. That's an alarm for anyone. Looking at 2022, they went and started looking at this, and they found that about 80% of the businesses that they surveyed reported that they were victims of a supply chain attack. It's a red alarm. I mean, those are sobering statistics when we think about that. That 80% of businesses that they surveyed were victims of a supply chain attack. It's crazy. Let's move to the next slide, because this problem is real. And we're seeing it here. If we look through the data that we have access to here, in our case in the U.S., this is a function of CISA, the Department of Homeland Security's agency, CISA, and they have really started doing a good job of measuring that. But it's really only been in the last year. But we can see that there has been evidence of this activity at very similar levels to what the ENISA has been reporting, predating that. In 2019, Operation Shadowhammer, this is one that affected about 54,000 endpoints. I'm sorry, 57,000 endpoints. What the best estimates is that the initial 57,000 resulted in a backdoor to be implanted in about 1 million devices before it was captured. The vulnerable system here was an ASUS computer piece of software. There were very few indications, very few indications that there was anything wrong with the software. It only was after people that did know what normal looked like on their network found that there was actually a backdoor that was being placed by this piece of software that was being distributed by ASUS. Again, that one-to-many relationship. Let's go to the next slide, because I think Operation Shadowhammer is something we really can kind of latch onto as a great example. Bank info security, or a media outlet that has nothing to do with manufacturing, but they latched onto this because it affected every type of organization, from high finance, banking, all the way through manufacturing, even into consumer electronics. And this was an example of this downstream attack, an attack against ASUS specifically, and compromising the software library, allowed what seemed to be a state-sponsored but yet opportunistic access for a backdoor to be placed across all of these organizations. And so the fact that this attack really, there was so few indications of this attack being successful. And when it first happened, the dwell time here was months, and some even estimate up to years. So bank info security, they're pretty good about covering that, and the potential, because it was not well communicated through certainly the media, of how long this potential access could remain. Let's go to the next slide, because I want to get through this part and talk a little bit more about like lower level attacks. Now, earlier I referenced the ISA 95 enterprise integration framework and architecture. And again, we're focused on IP connected devices in this conversation. If we look at the things that are common, right? How do we connect all of our HMI, all of our IoT, all of our stuff to those IP networks? But generally, those are done through Ethernet switches. Even our wireless networks have to transit their data back through Ethernet switches. Well, in 2020, there was a supply chain attack that introduced thousands of counterfeit Cisco branded switches into the supply chain. These were fairly widely distributed, but it just happened to be one business that was overly vigilant around verifying the authenticity of the Ethernet switches that they introduced into their environment. So this supply chain attack extends down into firmware and even hardware in this case. Let's go to the next slide, because I think it's important that that we talk about in that hardware piece. Oftentimes these are really, really difficult to attack. Now, no talk on supply chain security could be complete without talking about Log4Shell. Now, I don't know if you've heard about Log4Shell, it was the proverbial dumpster fire. I mean, it was as bad as it possibly could get. I know the weekend that it came out, I don't think I slept. We had many of on our team. We were scrambling, trying to find all of the possible places that this could be. Now, I won't bore you with all the technical details, but Log4Shell was a Java library. It was a tiny little component of a piece of software that is in just about everything from network video recorders to consumer electronics to cameras to access control systems. It was everywhere. Conservative estimates place the impact here to be greater than 1 billion devices in the United States. Now, just think about that for a second. 1 billion devices, 1 billion pieces of software, computers, manufacturing equipment, 1 billion devices have this vulnerability, which means every software vendor that published software that might have used this library had to go back and update the software. A lot of those vendors, the software is end of life, end of support. I know in my experience on the HMI side, we saw this on a huge number of HMI devices, and the manufacturer of those devices, they had long since end of life those devices, and they had no intention of going back to patch them for this vulnerability. So oftentimes we see these vulnerabilities just abandoned, they kind of linger. They're still there. So Log4Shell, 1 billion devices. Let's go to the next slide because right, you can see this is like a dumpster fire. Well, I mentioned Okta earlier, and I can't get out of this section without talking about Okta. This is hot off the presses. Right? This happened 2 days ago. And specifically here, an Okta employee, again, this is a security company. This is a company who is at the core of authentication. So the heart of security for many things. A threat actor targeted an individual employee, exploiting a policy that at this point it's suspected that it was known, but exploiting a policy that allowed those employees to simultaneously access a personal email account while also on a corporate work computer. And I'll spare you the boring details here. It's not boring. It's actually really fascinating. But look at the name of those affected customers in this breach, or in this incident. Right? Cloudflare, front-end security for thousands, hundreds of thousands of websites. 1Password, that's a password vault. That has millions of customers and hundreds of millions of passwords for those customers. Beyond Trust, that is an identity and access management platform. They are these are all security companies, and those are only 5 of the affected companies that we know of right now from this Okta breach. These attacks are very sophisticated and incredibly difficult to detect. They're happening at the highest levels, at the biggest companies with the most robust security posture. If it's happening at Okta, it's happening everywhere. And let's go to the next slide, because I think now that we can understand, right, this is a big deal. But why? Why now? And I mentioned earlier that CISA in the US has been focused on this. They have been building capabilities in this extensively. This is one of the elements of the 2023 CISA planning agenda, one of the national priorities. And this statement, I think, summarizes it all. That simply, it's easy. The threat actors are going to the path of least resistance. And in this case, it's our software. Let's go to the next slide, because one of the things I wanted to share, I mentioned this, is at the national level. Back in 2021, President Biden signed this executive order on improving the nation's cybersecurity. Now, you'll notice right there, Section 4, and I'll blow it up. Go to the next slide. Let's look at it a little bit bigger. Section 4 specifically calls out software supply chain security. And that really is that waterfall attack, that 1 one-to-many relationship. This is quite literally at the highest level of the national cybersecurity priority. It is in this document. Let's go to the next slide. If you haven't read this executive order, I would encourage you to do so. It really is quite well written. It names specific technologies, and it's something that I think that as professionals that are just being aware of the world, what the federal government's focused on, I think it really can inform our view of what the threats out there landscape. Now, I want to take just a second. I'm going to be very brief in this purposely around ICS, industrial controls. Now, you'll see these controls, these identified controls that are up here on the top. Those are referencing the Center for Internet Security, or CIS controls. We're going to talk more about the CIS controls in a few minutes. But these areas, these specific controls, are where we see the highest number of vulnerabilities, the highest number of exploitation of the controls, of those individual controls inside of the ICS space. 2022 saw the highest number of CVEs, of vulnerabilities being reported in history, specifically in the ICS space. So where are the biggest vulnerabilities that we're seeing? Well, we're seeing uncontrolled remote access. So we're specifically by third parties, the lack of knowing what normal looks like, what network flows look like, what third parties, what devices, what systems, what network protocols are those ICS devices that are on the network, what's normal for them to go make calls to, make connections to. And there's a wildly incomplete inventory of software and firmware versions across most organizations. Very often when we talk about an inventory of IT things, it stops in the IT department. No one ever thinks about what's happening out in the manufacturing plant. But theirs are very complex systems and computers that are out there too, and that inventory has to be taken into account. So put a pen in the CIS controls there. We'll talk about those more in just a second. Let's move to the next slide, because now that we understand that OT, ICS, and IT, these things, the supply chain attacks are affecting every one of them. There are wildly disparate capabilities, especially in the OT, HMI, and ICS systems. We've been able to patch IT systems for a long time. That's kind of old hat. But patching an OT system or a ICS system or an IoT system, that's a different thing, right? Incredibly limited downtime windows. I know of facilities that have hours per year of planned downtime. We have decades, not years, but decades of entrenched practices that we really do have to break, right? It's that's the IT stuff, that's a security thing. They do that with the computers. We have to break that mentality, and we don't have a consistent set of requirements, a consistent level of requirements across all of our vendors, going from IT all the way to the smallest microcontroller on a platform. Let's go to the next slide. These collectively are a national security issue. That's why it is in the cybersecurity directives in the executive order I mentioned, as well as in the cybersecurity planning agenda for CISA. But let's put all these data points together for a second. Now, I titled this "All Roads Lead to Breach." I hope not. I hope not, but that has been what we've seen time and time again. Now, the couple of data points that I think are relevant here, and that's regardless if you're in the enterprise space or you're in a small business. Understand that these things are applicable in both sides of that. Small businesses are the most targeted business demographic. Multiple data points tell us that year over year. Generally, external vendors are SMBs themselves. It's very unusual to see an enterprise organization only doing business with another enterprise organization. There are SMBs that are in that ecosystem. About 80% of the SMBs out there in the United States rely on one or more IT managed service providers. The MSPs are almost always SMBs themselves. And our OT and ICS systems that are now network connected, that are now accessing cloud systems, that are now network aware and talking to each other, they very often are lacking even the most basic cyber capabilities. This last point is for the business types that are on this call. Very, very often, SMBs have inadequate risk capacity. They don't have the ability to quantify the risk. They don't have the insurance to transfer that risk, and they're unaware of the risk that they're inheriting when they make business connections to other vendors, to other suppliers, to other customers even. And meaning that in the event of a bad thing happening, that very often those SMBs are left holding the bag and they don't have anyone there to help them. If we can move to the next slide, please. I'm not sure if where that left off. Whereas my point though with these small businesses having inadequate access to be able to transfer or accept the risks that they have, what we've seen is we've seen continued access to ecosystem partners with extreme levels of trust and access. How many have a VPN connection, as an example, have a VPN connection for a third-party vendor that they not only can access the systems that they need to, but everything on the network. Threat actors are leveraging this, they're exploiting this, and they're using it. Most SMB manufacturing organizations have few to no dedicated cyber resources. And as you'd expect, the IT and the technologists that they have, they're focused on the manufacturing side of the business. They're focused on the things that make the business money, and that often doesn't start with cybersecurity. But simply, all of this sums up as functionality over security, access over authorization. That has been the standard for so long, and we have to break that. The threat actors know this. They're exploiting these vectors on a daily basis. Let's move to the next slide and talk about some solutions for this. Because at the end of the day, all of this means that we have unlocked the coveted achievement of a cyber dumpster fire. And I don't think anyone wants that. So let's move on. And one more slide. So I mentioned earlier around the CIS controls, and I'm gonna unpack that in more depth here in just a moment. But the CIS controls, and the reason I mention that here, the CIS controls are a really good place to get started, and that is often what I'm asked the most. Is like, okay, great, I got it. We have all of this terrible stuff going on out there. It's bad, but where do I start? The guidance I would offer there first is to understand the attack etymology and the motivations. How are the bad guys doing the bad things that they're doing? Who are they targeting? How are they targeting? What are they getting to? Assume nothing in that understanding. Assume that you don't have cybersecurity, don't have controls, you don't have those things. So start with a zero base and start building a map, an understanding of what's normal, right? What are those command and control endpoints? Where are all the pieces of software having to go out and make connections? And sometimes that's asking your vendors, asking your MSP. It can be technical audit and assessment of the network flows themselves, but seek to understand that. The more that you can understand what normal is, the faster you can arrive at a time to value and a time to action when you see something that's not normal. But I also think it's important that we have to zoom out. It's easy to talk about the things that have blinking lights and wires hanging out the back of them. But we also need to understand what's important to the organization. Not all systems, not all technology, not all things are of equal importance. It's important to understand what is important to the organization, and then understand what security controls are there to protect each one of those. Lastly, and this goes back to the point of the CIS controls, because we're going to dive in there in a moment, utilize a standard framework, whether it's the CIS controls or any others that are out there. There are many, we'll talk about a few examples here in a moment. Utilize a standard framework to prescribe and quantify risk coverage of the risks that you have, of the way that the bad guys are doing the bad things. All right, if you understand that, what controls do you have that cover those areas of exposure? So let's move to the next slide, and we can talk a little more about this. Now, there's incredible amount of resources that are available to us, and this does not take a technologist that only spends time in cybersecurity. I think this is very approachable. These resources that I'm going to share here are very approachable because it does a good job of quantifying that attack etymology, and then how do we move from there. So first, I'll introduce the cyber kill chain. For those that have any military service, you'd recognize this in the kill chain. Very, very similar, 7 phases of an attack, where this is 7 phases of a cyber attack, beginning at a reconnaissance and then completing on the threat actor, carrying out the actions on the objectives. Now, the cyber kill chain maps out to the MITRE attack framework. As with all things IT, we have a great another acronym here, and that is ATTACK. ATTACK is the adversarial tools, techniques, and common knowledge framework. This is something that is free, it's accessible to everyone, and it maps the phases of the kill chain and applies very, very specific tactics that threat actors use to carry those out in each of those phases. So we can communicate incredibly precise tools, techniques, and practices that threat actors use using the MITRE attack framework. Let's get to the next slide. So this is the way to understand how the threat actors behave. We can communicate in a common language that is shared across the security industry and increasingly across the business industry, even of being able to understand the different phases of an attack, the different the way that it progresses and when it progresses from each phase of the kill chain forward. Now, I mentioned the CIS controls. I am a accredited CIS assessor. I've been working with controls for about 13, 14 years now. So I'm biased. I'll be transparent. I'm biased toward the controls, but there are a number of good frameworks like this out there. My point here is I encourage you to pick one that you can understand. I like the CIS controls because they're written in English, and for the purposes of the rest of this conversation, we're going to kind of frame it in the language of the controls, because it doesn't require a PhD in risk management to understand what they're trying to get to. So let's move to the next slide and zoom in on them with a little bit. So the CIS controls, what makes them different from all the others is they're less prescriptive, they're more outcome focused. They are developed by a group of about 3,400 of us that are on the working group that inform the development of the controls. And it's done with an offense-informed defense methodology. How did the bad guy carry out the attack? Let's make sure that we have coverage for the way that those attacks are being carried out in the controls. And it is, again, offense informs defense. That is, it shortens the time to value and really allows us to focus our resources in the areas that matter the most. They also allow, especially in smaller organizations, control and gradual changes toward the objective. So we don't have to bite off everything at once. And then, I don't know if anyone else has been through this, but you have a security program that launches and it just stops everything dead in its tracks. And then the program is abandoned because it's too hard, too disruptive, too fill in the blank. The controls really help guide our efforts toward that to be more controlled and much more impactful, but less disruptive. Let's move to the next slide. I want to just very quickly talk about the way that these are risk-sized groups. This isn't a talk on the CIS controls. I'm not going to go into all of the risk management with this, but I think just for our purposes of being able to quantify where risk fits, and it's important to understand what risk and where you fit in this ecosystem based on what information risks you have. The controls are organized into 18 control areas, and those control areas each have a number of safeguards that are underneath those, and those safeguards are progressively more difficult, more complicated to implement. One or more safeguards is aligned to these implementation groups, or IGs, starting with IG1, which is the most basic controls, up to IG3, which is really intended to prescribe a set of controls that are appropriate for very sophisticated adversaries. Now, I want to focus for just a second on IG1 because that is really basic cyber hygiene. This is the brushing your teeth, taking a shower, changing your underwear of IT. It's approachable to everyone. And that's the point. Let's go to the next slide because I want to illustrate kind of how this works. These are the 18 control areas of the CIS controls. And you can just, you can download them off our website or the CIS website. You don't need to memorize them. But let's go to the next slide. Inside of each control area, I mentioned that there were a number of safeguards. And the safeguards that are identified here, they align with one or more of the implementation groups. And so you can see this is how they're organized. So as an example, an IG1 organization doesn't have to consider control 1.5. They don't need to have that that technology because that's not risk appropriate for their risk profile. Let's go to the next slide. Understanding kind of how they're organized. Again, focusing on 18 control areas, individual safeguards, and each safeguard says do one thing. Very outcome focused. It doesn't prescribe a technology, a methodology, a vendor of how to do the one thing. It's do one thing, accomplish the objective of that safeguard, and you meet it. And so that allows it to be applicable across lots of different industries, organizations of all sizes. Let's go to the next slide. So understanding that IG1 is the brushing your teeth, taking a shower of cybersecurity, the Australian Signals Directorate, their NSA, if you will, they did an analysis of a whole bunch of different security frameworks. And they found that the CIS controls were effective at implementation group 1. They were effective to mitigate 78% of exposure to ransomware attacks. Now, I don't know about you, but I'll take 78% all day long with a basic set of controls. That's huge. So we have in this case, a foreign government who's doing the analysis. They've quantified this, and we've seen the same type of data of actual quantification of the efficacy of these controls repeated time and time again. The controls are effective. The point. Let's go to the next slide. Now, understanding that the controls, what they are, where they are, I want to talk for a minute about the shared areas of exposure. Right. That was the kind of the thesis here of this entire talk. Shared areas of exposure. We do a lot of assessment. We do a lot of risk assessment and actual exposure assessment as part of our core business. And just to set the stage for the next couple of slides here, what I've done going back to 2020, we started overlaying the data from the assessments that we're performing, and looking at where there were what they look like on a radar plot. This actually originally showed up as we thought it might be an aberration in the data because there were lots of areas that just overlapped, and we thought that was bad. So just to set the stage of what you're seeing, there's a radar plot that'll be shown in the next couple of slides. Around the perimeter of that radar plot are the individual control areas. Control area 1, 2, 3, so on and so on, and then the area of that plot is focused on the percent of the practical elements of the controls that are implemented. And what I mean by that is the doing it parts of the controls. Not that there's a policy that's written or anything else, but the doing it part. So let's go to the next slide. What we found.
Hi, Lawrence.
Yes.
I hate to jump in, but we have hit the 1 hour mark on the webinar. And we do have a question that came in. So I don't know if we could wrap this up to at least get to one question, because we did promise the folks it would run 12 to 1.
We absolutely can. Let me cover these next 2 slides and we can move right to questions. How about that?
Okay.
All right, fantastic. So what I want to share here, and thank you, Elizabeth, for the time check. These shared areas of exposure, what we found going from 2020 up to 2022 is we found that looking at state and local government, small to mid-sized business, and MSPs, that we found that there were these common areas where there were weak implementation or low scores for implementation. Let's go to the next slide. And specifically, these areas that are highlighted I have them called out here so you don't have to write them down. Go to the next slide. But these shared areas of exposure, what they identify is really it's a roadmap for an attacker to carry out an attack. It's these 5 control areas really are where they are. If we go to the next slide, I would hope, right, that 2023 there's been lots of attacks. Well, 2023 is shaping up to be largely the same. So this is something that is still out there. The point I want to make with this is this is characteristic or likely characteristic of the organizations that are inside of your ecosystem. If the controls that you have internally, the controls that your vendors, your MSP, your customers and other suppliers, if there are similar areas of weakness around all of the, or similar areas of weakness across all of those different entities, those are areas that the attackers are going to exploit. They are going to take advantage of. So I would encourage you to understand those so that you can best defend yourself. And for the purposes of time, if you would go toward the end of the slide deck, and this slide deck will be made available to everyone. There are, and you can just go through these slides. Each of these next slides have one or more tools that are available, that are out there, that are free to low cost, that you can use. I would encourage you to involve your IT people in the conversation, or your risk management people in the conversation, just to understand where you are and what, where there may be some shared areas of risk that you have inside of your organizations, and if those tools are. So with that said, together we can make a change. Together, it will take a community to make this, to actually make a difference. This is a team sport. So to that point, I would encourage you, if there's questions you want to ask in this shared environment, happy to take them. If not, this is my Twitter X handle and my direct email. Please feel free to reach out, and let's keep in touch.
Wonderful. Thank you, Lawrence. I appreciate the presentation. I'm glad we got through the technical difficulty and got you back. So thank you again, Lawrence, and I hope everyone has a terrific day.
You can listen to all of our episodes of Manufacturing Matters and Lunch and Learn podcast from the MFG Radio Network on Spotify, Apple Music, and on our websites, todaysmedicaldevelopments.com, aerospacemanufacturinganddesign.com, defenseandmunitions.com, and evdesignandmanufacturing.com.